Alright, in this video, we're going to summary the properties of scalar product. It's a very short summary, okay? As I have already discussed I have proving some properties for you, and I described some useful properties of the scalar product, right? Now I'm just going to summary it in a simple form so that you know what is important, alright? So the first one will be, if I have vector A dot with vector A, it will be rewrite as a magnitude of vector A square, and you should not write in this form, okay? This is not a number, it's not a number, right? It's not an algebra that represent a number, it's an algebra that represent a vector, so you shouldn't write this way, right? This is very wrong, right? Because all this will be based on the definition of dot product, okay? All is result from the definition of dot product. So which is A dot B is the same as the magnitude of A, magnitude of B, cosine theta. So, and secondly, so A dot B is the same as B dot A, right? Based on the result. So as this is a scalar, right, you will produce a number, and B dot A, you also produce the same number here. So I have explained this in the previous video about the useful result from the scalar product. Okay, another thing here will be, if I have A dot B, the result, if I getting A dot B to be 0, if I find out that when I taking a vector A and a vector B, when I do a dot product, I getting a 0, okay, a scalar 0. This can actually show that if and only if the vector A and vector B are perpendicular. Vector A is perpendicular to vector B, right? All this is very important. So this 3 is the most important. So if you know that 2 vector, when you dot, you must write in the form of magnitude of A square. When you say that A dot B is the same as B dot A, definitely this two will be the same because they produce the same scalar. So, and if you find out that A dot B is 0, then you can say that A is perpendicular to B. Or if you say vector A is perpendicular to vector B, means that the angle between the two vectors are perpendicular, 90 degrees. So then the A dot B will be 0. And this 3 was a very important concept, properties here. And we also can say that A dot B is the same as B dot A. This we call it as commutative. They follow the commutative properties. And also, let's say, okay, this is the 3 important one, okay? Later on, of course, in this video now, I just talking about when I still discussing the concept of scalar product, right? So I'm talking about scalar product. Later on, when we learn about vector product, I'm going to compare between the vector product and the dot product, and how to deal with dot product and cross product at the same time. Means that the property involving both product. All right. So now in this case, we just summary for these subtopics about the scalar product. This is a very 3 important concept here. So of course, the fourth one, let's say if I have A dot with vector B plus with vector C, we can say that A dot with B plus with A dot with C, and scalar product also actually follow the distributive properties. All right, the scalar product is distributive across addition. All right, across addition, you can actually expand it. Okay, just like you expand an algebra, but you must remember to put a dot here. A dot B plus with A dot C. So this is some important result so that you should know. And of course, previously we have discussed about, let's say if 2 vector, all right, if 2 vectors are parallel, right? If 2 vectors are parallel, so either they are parallel in the same direction or opposite direction. So if they have the same direction, the angle between the 2 vectors will be 0 degree, right? If they have opposite direction, the opposite direction of each other, so we say that the angle will give to be negative 180 degrees, right? But I'm going to tell you again that this 3 is the most important one and tested by your examination, okay? And this is the also that you must know, right? So then if you have based on the definition, right? Based on the definition. So if they have same direction, I can say that A dot B is the same as magnitude of A multiplied with magnitude of B. Because why? Cos 0, right? If you have cos 0, if these two are parallel and in the same direction, the angle between them is 0. Cos 0 will give you the value of 1, right? So this one, if they have the same direction. So if they have opposite direction, okay, if they have opposite direction, the dot product A dot B, it will be magnitude of A, magnitude of B, cos 180. Cos 180 is negative 1, right? So means they will have negative magnitude of A, magnitude of B, right? If you want to show that the two vectors is parallel and having the same direction, the product of the value of magnitude of A and B will be the same as the scalar produced by A dot B, right? And this is almost the same, just there is a negative here if they have opposite direction, all right? So scalar product is distributive across the addition, and this 3, A dot A is the magnitude of A squared, right? So and A dot B is same as B dot A, and this A dot B will be 0 if and only if the two vectors are perpendicular to each other. Alright, so I have tell you this is a summary of a scalar product. That's all for this video.